All right, today your goal is to continue looking at the constant of proportionality. We're going to be comparing two different sets of values today. You're going to use tables to do this. You're going to use graphs to do this. You're going to look at the equations. So I wanted to give you an example. In our example, Cindy is comparing two cell phone companies to find the best value. She has to pay by the hour. On-call charges $10.50 for 3.5 hours, and talk time charges $1.25 for 1/2 hour. Here are two tables. I know this one is talk time because I see that it's got the $1.25 in the 1/2 hour, which would mean this one is on call. So the first thing I want to do, let's say that we only have the tables to do these comparisons. So what I'm going to do is I'm going to complete them using rational thinking, right? Proportions, ratios. All right, to go from a 1/2 hour to a whole hour, it takes 2 half hours to get 1 hour. So I'm going to also multiply $1.25 times 2. That's going to keep things equal. Therefore, 1 hour with talk time costs $2.50. All right, let's keep doubling because to get from 1 hour to 2 hours, I would double. 1 hour times 2 equals 2 hours. I'm going to do the same thing here to maintain equality. $2.50 times 2 is $5. Lastly, I'm going to keep using a multiplicative relationship here. Let me clean this up a little bit to show you what I mean. I'm going to use that 1 hour. And I'm going to use that to scale to 3. So 1 hour, to get to 3 hours, I need to triple it. I am doing 1 times 3 equals 3. So to keep it equal, also multiply this by 3. $2.50 times 3 is going to be $7.50. For on call, here I did this a little bit differently. When I saw the 3.5, it was a little harder for me to figure out a calculation to get down to the 1 hour. So I started by actually scaling up in order to get a whole number. I know that 3.5 times 2 equals 7. So let's also multiply the $10.50 times 2. $10.50 times 2 is 21. Now I have a whole number to work with. And so then I thought of scaling down to get to 1 hour. 7 hours to get to an equal number of 1 hour groups, I would divide it by 7. 7 divided by 7 is 1. Maintain equality by doing the same thing here. 21 divided by 7 is 3. Because that is going in the cost column.
Miss Reese, please call the drum office. Miss Reese, please call the
There's an
drum
announcement
office.
to interrupt us. Because that's in the cost column, that means it costs $3 for 1 hour at on call. And then lastly, to get from 1 hour to 2 hours, I'm doubling. So I'm going to double the cost, which would give me 6. I could put this as money. All right. So if I'm just using the tables to give Cindy my opinion on what the best value is, I'm going to look at hours that are equal to each other, right? So I could say, oh, well, at 1 hour, talk time costs $2.50. At 1 hour, on call costs $3. That means you want to go with talk time because it's the cheapest. So there's one way of looking at it. That's how the tables will help you. Let's talk about how the graphs can help you. So first I need to label my axes or my axes. Time in hours is along the x-axis. Cost is along the y. So the hours I have range anywhere from a 1/2 hour to 7 hours. I'm going to skip a line in between each. For cost, I'm going anywhere from $1.25 to $21. So here I'm not going to skip a line. $1, $2. This will take me all the way up to $10. And now I'm ready to graph. I'm going to stick with the same colors I used in the tables. So talk time is going to be graphed in blue. At a 1/2 hour, which would be here, then that cost $1.25, which would be right about there. 1 hour was $2.50. 2 hours was $5. 3 hours, $7.50. So there are my points for talk time. Here's the other thing I would know. If she doesn't talk at all, she has 0 hours, I would expect they're going to charge me $0. So 0, 0 would also be a point on talk time's graph. Now, I'm going to draw a line through it. This would cover all those numbers that could be in between there, like maybe she talks for an hour and a half. Maybe she talks for 2 hours and 15 minutes, right? Okay, there's our talk time. Now let's graph on call. At 1 hour, it was $3, so that's pretty close. Again, I could also say 0, 0 is a point because I'm not going to pay for 0 hours. 2 hours to $6. 3.5 hours to $10.50. That's going to actually take me off the graph a little bit. Here's something else I've noticed. I could get 3 hours here. If 1 hour costs $3, 3 hours would cost $9. So I could use that to get another point on the graph just so I can more clearly see where my line's going to go. Now I will also draw a line here. Notice both of these lines are straight as I can draw them by hand, and they both go through the origin. Remember that those things are what tell me it's proportional. If they didn't start at 0, not proportional. If they weren't straight, not proportional. So how can the graph help me to compare values? Well, I'm going to look at the slope of the line. In this case, time is a constant thing, right? It's going across in half-hour increments. The thing I'm looking at is the steepness, meaning how high does this line go up? Like how angled is it? Because the y value is the cost, that means the steeper the line, the more expensive it is. This is another way to maybe think about that. Let's look at 3 hours. So here's 3 hours on the graph. At 3 hours, talk time would cost this much, while on call would cost this much. That's showing me that on call is more expensive than talk time. That's another way of looking at it. You will have to use graphs like this today and compare and analyze what it means. So I highly suggest thinking about what the labels say and then paying attention to the steepness of the line. So one more time here, the steeper the line, the more expensive it is since the y value is the cost. All right, so that's how I could use the graph to show her. Let's talk about finding the constant of proportionality from this graph and then how we could find it from the table. So the constant of proportionality is found by doing y divided by x. R is what represents the rate or the constant. There's a couple ways to look at it. We know that the rate is where x is equal to 1. So one option, in a table, I could find this by going and looking for where x equals 1. There it is there. There it is there. That means for talk time, the rate or the constant of proportionality would be $2.50. For on call, where x equals 1, y is $3. So that tells me the rate for them is $3. What this means in terms of the problem situation, y here is the cost, x is the hours. So that means the rate here would be $2.50 per hour for talk time. And then for on-call, it'd be $3 per hour. So that's one way to find the unit rate. If I'm sticking with the x equals 1 scenario, I could go to this graph. And here's 1 on my x-axis. Talk time hits at 2.5. It's right there in the middle, right? So talk times rate would be 250. And then I see that on-call hits right at 3. So their rate is 3. It's going to be the same answer, right? It's the same information. It's just another way of finding it. You could also use other points from the graph. So let's say, or the table as well. Let's say I chose this one and this one. Well, if it's y over x for talk time, with this point I chose, it's going to be 750 divided by 3. And that comes to equal 250. Same answer, right? For this one on call, it's going to be 21 over 7, which equals 3. So their rate's still 3. The last thing I want to remind you of is how to write an equation for the constant of proportionality, or including the constant of proportionality. For talk time, if the rate is $2.50, the equation will always take the form y equals r times x, where r is your constant. So I'm going to just rewrite it and replace the r with the 250. There's the equation for talk time. Then I look at on-call. Their rate is 3. Y equals, replace the rate with 3, multiply it times x. There you go. It's a lot of information, but just keep in mind y over x to find the constant. Any place where x equals 1, that's a unit rate. That's your constant. And make sure you're reaching out for help as you need it.